Riddle me this, capitalism. All right. Hi. None of your business. Swear to God, I will destroy the internet if it means I get peace and quiet. All right. So. What? Okay. How do you solve a problem like Maria? Extend the lines. You guys are like, I have no idea what we're doing, but we're going to extend them. That's all I remember. Fair enough. Taylor, it is good to have you back, complete with new hair. Looks pretty much the same. Waste of money. All right. I have extended those lines. Now we have 3 transversals here. Which one would you like to extend so we can focus on it? The middle one? Great idea. First hour is best hour. Okay. So now we can focus on that and ignore these guys, right? And as you can see, we have 2 transversals being cut by a... We have 2 parallel lines being cut by a transversal. Wonderful. Now what does that mean about the corresponding angles? I swear to God. What does that mean about the corresponding angles? They will be?
Equal.
Congruent. Very good. Thank you, Taylor. Taylor learns more when she's not here. All right, so check it out. This angle right here corresponds to this angle right here. Don't it? We have top left corner of its intersection. Here's the intersection right here. Again, ignore this line. There's the intersection, right? Ignore this line. There's our intersection, top left corner, which means this is x minus 4. Now, what does that tell us? Bless you, child.
Thank you.
Don't do it again.
I'll try not to.
Thank you, Bo.
Oh, yeah.
Oh, yeah. What does this tell us? Anyone other than Taylor?
X minus 4
Yeah, check it out. We have vertical angles here, right? Which means these 2 angles are going to be congruent. Which means that x minus 4 equals 3/5 x. So that's handy. That's handy. How do you solve a problem like Maria? What? Mm-hmm. Yes, I do. Next question. Against my better judgment, yes. I'm not sure about that. You can't use my nice ones. You can use these. Jenna, you're looking very fall today. Yikes. Yikes.
Got it.
Go on. Wait, there's more? All right, we don't have time for this. Everyone, totally focus over here on the math, of which you were very interested in. All right, so check it out. I'm going to get my x's together. Terrible idea in life, but great idea in math. I'm going to subtract 3/5 x to this side. So what I get is 0 over here. And if I've got x here, I've got 1x, right? And I'm subtracting 3/5 x from it. So how many fifths of x do I have left over? Try again. 2/5, right? Because that's 5/5 of x, right? 1 is the same thing as 5/5, so subtracting 3/5, I have 2/5 left over. Then I'm going to move that 4 yawn over, and I get 2/5 of x equals 4. Now, what do I do to get x on its own? Multiply by the reciprocal, right? which tells us we're going to multiply by 5 halves to both sides. Now, if you don't like the reciprocal, that's fine. I'm going to do it without using the reciprocal. If you like the reciprocal, knock yourself out. What will happen is we'll multiply by 5 and divide by 2, right? Which is going to be the same thing I do. It's just going to happen in 2 steps instead of 1. So if I want to get rid of this divides by 5, I would multiply by 5, right? And if I want to get rid of this top part, that means times by 2, I would divide by 2. Which would you rather do first? Divide by 2 or multiply by 5 first?
Multiply by 5.
Okay, so the 2 stays with the x. And we multiply by 5, and that makes this a 20. Right? The times by 5 gets rid of the divides by 5 on this side. And the times by 5 on this side makes that a 20. Now I divide by 2, and we find out that x is 10. Again, the bottom part is division. The top part is multiplication. You can get rid of them in either order. We could have divided by 2 first and gotten 2 over here and a fifth over here. And then to get rid of a fifth, we get to multiply by 5. We get 10 anyway, right? So same dumb crap. This angle right here is going to be 10 minus 4, which is 6. And this is going to be 6 as well. And we know by vertical angles these should be the same. So whatever 3/5 of 10 is better be 6. Guess what it is? That's also 6 degrees. Because they're congruent.
Yeah, but like,
You could have also done 3/5 of 10, which is 10 divided by 5, right? That's what that 5 in the bottom means. That's 2 times by 3 in the top, 6. Okay. All right, so we've got that. Now what? Yes, Jerkica.
are the angle like one that's full wide? No. No. The little to like, no.
I've chosen all the angles.
No, the one like right next. Yes. Is that congruent to 8y? I like right.
All right, so she thinks this is congruent to 8y. Let's check it out. Here's our intersection here, which means if we extended this out, these angles would be corresponding, right? So that would be 8y. Now, are these angles vertical?
Yes.
Yes, they are. So now we know 8y plus 4y plus 6 is going to add up to 180 because they're all collinear. Right? Well done. 8y plus 4y plus 6 equals 180. Are you with me? How many y's do we have on this side? 12 y's. And when we subtract 6, we get 174. Now the question is, how many times does 12 go into 174? Well, 12 goes into 120 10 times, right? So 10 times gets us to 120. How much is left over? If I'm at 120 and I need to get to 174? 54. How many times does 12 go into 54? Well, I know it goes into 48 4 times, right? That leaves us with 6 left over. How many times does 12 go into 6?
0.5.
Half, right? 14 and a half. So y is 14 and a half. So now we go to plug this in to figure out the angles. 4 times 14 and a half is that purple angle. Well, 4 times 14 is 40 plus 16, right? Because 4 times 4 is 16. So 40 plus 16 is 56. 4 times a half is 2. So we get 58. And now that I know this is 58 and 6, I know that makes 64. And whatever this is should add up to 180. So if this is 64, and the whole thing should be 180, we do 180 minus 64, and that's going to be what this is, right? So what's 180 minus 64? What's 180 minus 60? 120. Now subtract 4 more. 116. Cool. Ladies and gentlemen, we got him. Put that away. Let us do our warm-up. Lettuce. Headache from hell. Headache from hell. Headache from hell. I could be a punk rocker. Ha! You have your warm-up sheet? Because it's time. It is time. It's all about time. It's always been about time. It always will be about time. Here's your warm-up for today. Oh no, hold on. Jerica, calm down. Calm down.
Are we turning this?
No.
Oh my
Ha ha. Fortunate last name. All right, here it is. This is a graphing story, meaning you need to make a graph. X-axis, Y-axis. X-axis will be time. It's going to walk you through it. Here you go. We'll play it a couple times. I feel like this song is fitting.
Come up to meet you, tell you I'm sorry. You don't know how lovely you are. I had to find you, tell you I need you, tell you I set you apart.
Now we listen.
Tell me your secrets and ask me your questions. Now let's go back to the start. Running in circles,
Going back to the
coming in tails, heads on the sides apart. Nobody said it was easy. It's such a shame for us to part. Nobody said it was easy. No one ever said it would be this hard. Oh, take me back to the start.
Get it? It's hard. Go back to the start.
I was just guessing back to the start.
Abrupt cut. That could be a band name. Hello. Let's see what their answer was. There are lots of ways to think about this. The size of the hand.
It was about a little over.
Are you confused? Anybody do that? You?
Kinda, sorta.
Does anybody want to explain why it looks like that? Luke!
Because you're passing cars out for, so you give one to everyone, and then it takes a while to give everyone one, and you have to give everyone two.
Sure. So our hand size initially is 0, right? The way they thought about it was everybody has 0 cards until everybody has 1 card. So while person A that you're passing to might have 1, everybody else doesn't, and so it's still 0 overall. And then at 3 seconds, almost exactly, that's when everybody has 1 card, right? And it stays at 1 card for another 3 seconds until all the cards are dealt again and everybody has 2 cards. So that's how they interpreted it, right? You could have done it differently. You could have said, right off the bat, there was at least 1 card, right? And then bam, we have 2 here. And then bam, we have 3 here, right? Et cetera, et cetera. Anybody else interpret it differently? Have a different graph that they think is just as valid, but a different way of looking at the question? No? Does anybody have these connected, where it's like a line that's slowly going up?
Yeah, that's what I.
Okay, so if you had a line that was slowly going up, what that would be is like the average hand size, right? So if one person has 1 card and everybody else has 0, right, the average is going to be very close to 0, right? And then as we start dealing more and more cards, eventually the average hits 1 when everybody has 1 card, right? So you could do that. That's another way to think about it. When I first did this one, I was, I don't know what you call this, but I was typical me. And this is what I did. I feel like other teachers just see me with sunglasses on and they think, wow, what a doof. They right. They right. So here's what I did. You ready? Explain. Yes.
It's like they have
You're right. It is constant. It is the same at all times. But they didn't have the same amount of cards, did they?
Your hand stick didn't do.
The hands didn't get bigger. His hands were always the same size. Haha. Idiots. All right.
Of course.
You don't play basketball anymore, but you used to, didn't you?
Nope.
Still do?
No,
Oh man. Some people just don't learn.
No, I don't. Never have. Never will.
You try out for the basketball team just for me.
You have to try out.
I did that once. I tried out, what was it for? Was it soccer? I think it was soccer, and I purposely just went out there and just did everything wrong. Like we're out in the field, steal the ball from my teammate, get in front of the goalie. I thought I was hilarious. I didn't make the team, spoilers.
Buckets.
Double spoilers, I didn't want to make the team. Hooray! Triangles! Get used to them, they're not going away. After we do this crap, we're going to go on to triangles and we're going to talk about congruency and how we can prove that two triangles are the same thing with the least amount of information possible, which is the beginning of the end for all of you. I like your scarf, Taylor. You're welcome. Superman sucks. I was driving home yesterday. I was like, man, it is so dark. Why is it like so dark and it's 5:30? It's awful. Who thought this was a good idea? Who is in charge? I have issues with them. And then I realized I'm wearing my sunglasses and I took them off and things are a little bit better. But it was still bad, right? It was still bad. I know. And then it was dark until 7. What the heck?
Okay, go off.
I'm mad.
Calm down. Are you mad?
Okay, so how do you solve a problem like Maria?
Did you call all of the problems Maria?
Yeah, it's a joke. It's The Sound of Music, the movie about Nazis, which I didn't realize was about Nazis until I was older. It's actually a very sad movie. Yeah, it's about the Nazi invasion of Austria.
The Sound of Music?
Yeah. Mhm.
I did not know that.
It's a-
I did not see how it's about.
It's fantastic. Well, probably because you watched it when you were younger and you didn't either make it all the way to the end because it's kind of a long movie, or you just kind of lost focus. Like the beginning of the movie is about Fraulein Maria, how she's like this terrible nun, right? And so what she does is she essentially leaves her convent to go take care of these kids and be a nanny, right? But she goes and she meets the juxtaposition to her, the admiral, right? Who's like the opposite of her, like super like rigid and like doesn't sing and all that crap. And so what she does is she converts their family and brings them together, right? It's this Mary Poppins type of deal. But then at the end, you realize that the girl who's like 16, I forget what her name is. It's what's her name? The oldest daughter. She's in love with this boy, right? And they're not allowed to be together. Well, it turns out the boy joins the Nazi contingent within Austria to join with Germany during the war. And the admiral, of course, being an Austrian, is like, no, this is bad, this is awful, which is why he rips up the Nazi flag when he sees it, right? But towards the end, what happens is they sing the Austrian national anthem, right, at this big thing where he's supposed to be like, oh yeah, Nazis are good or whatever, and so the Nazis get mad at him because they, sing this thing. And what they have to do is they have to flee the country and run away to the Alps. And what's even crazier is that this is a true story, right? So they did this defiance of the Nazis in this small little way, right? And then had to go run from them, yeah.
Are you on live?
I am, yeah. So that's The Sound of Music, spoilers. Fantastic film.
I just remember the part where they ran through the dungeon, and then when they were skipping the prairie.
Yes. So it's a very happy movie until you get to the end and you realize, like, man, Nazis suck, right? Which is why we should punch them every chance we get. All right. How do you solve a problem like Maria?
I'm gonna name myself Maria.
Maria's a great name. Maria, Maria. I just met a girl named Maria. West Side Story.
I
What's awesome is that song has a major seventh in it. Maria, right? That jump from the first note to the last note right there is a very big jump. And so it's a good way to help you remember what a major seventh is, music theory people.
We watched the movie
They don't have a
and
music
this
theory class anymore because nobody's going to college music theory anymore.
Yikes.
The
I mean,
last person was Cassie Osborne.
it's still fun to do it. All right, so check it out. These guys are associated with those angles, just so you're clear. And then this angle right here is what we're talking about. Let me zoom in. Yeah, Sound of Music. Awesome movie. Instilled at a very young age my hatred of Nazis. All right. Thanks, Grandma. Shout out to my grandma. You got dementia, and you don't know how to use the internet, so you're not watching this. But shout out to you. All right.
What if your grandma actually watched this?
That would be dope. What's up, Grandma? Thanks for watching. Like and subscribe. Yeah, notification squad. Oh, my grandson's live. Right? That's not what she sounds like. How do we solve a problem like Maria? What do you notice? Come on.
Okay.
Noah.
3x plus 5 is corresponding to y plus 8.
Ooh.
But that doesn't really get us anywhere.
So true statement. I'll take as true statement any day of the week. 3x plus 5 and y plus 8 are corresponding. Check it out. If I extend those out, don't we have a transversal? This guy right here. This line right here. A transversal that's cutting those two parallels. So top right corner, top right corner. So they're equal to each other. Y plus 8 equals 3x plus 5. That's true. It's not helpful because why?
Well,
Literally because why? Because why?
yeah,
Because we have two variables, and one of them is y and one of them is x. If both were x, we'd be fine, but one of them is y. So it's not helpful because why? Yes.
Okay, so like if you extend the two parallel lines,
Yeah, okay, now we're talking.
and then 3x plus 5 is vertical to the angle,
Ooh, yeah, so these are vertical.
and then those two at 180.
Good. Okay, so for Courtney, it was easier for her to see once she did this that these two angles are indeed a linear pair, right? Now, could we have seen that before? Yes, they're on a line right here. But sometimes it is easier when they're like that, where they're top and bottom, or bottom and bottom, or top and top, right? But these two are going to be a linear pair, which means they are supplementary by linear pair theorem. And by definition of supplementary, it means they add up to what? Very good. So 3x plus 5 plus 6x minus 14 is going to equal 180. Next problem. The rest you can do on your own, and you will for homework. How do you solve a problem like Maria? Ba-dum-bum-bum. Yeah, that would help. That's one way to do it. Who can give me a true statement that may or may not be helpful?
The box is 90.
Ooh. Okay, so you're saying that's 90. Does that mean this is also 90?
Yeah.
If they're parallel, it means they're going in the same direction. Right? This line right here is the same line for both of these parallels, right? Do you see how these parallels go through that same line? So they must hit it at the same angle if they're parallel. So yeah, that is 90, isn't it? Well done. So 9y, and we haven't really talked about that in here, but that's a true thing, right? The angle that this line goes from is going to be the same as this one because they're parallel, right? That's what it means to be parallel. They're going at the same angle. If their angles were different, they would intersect, right? So they have to be the same angle here and here, otherwise they wouldn't be parallel. So 9y is going to equal 90. Now what does that mean for y? It's going to equal 10, right? Okay.
So could you do like 5x?
Keep going.
90 equals 180.
Yeah, so check it out. Courtney's saying that these two angles right here are a linear pair, right? By linear pair theorem, that means they're supplementary. And if they're supplementary, that means they add up to 180. So 5x plus 90 is going to get us 180. Next problem. How do you solve a problem like Maria? Extend the parallels, right? First off, that's a good idea. Let us extend them. Lettuce. What's your favorite kind of lettuce?
I don't like lettuce.
Romaine. Iceberg. What about butter lettuce? You ever had butter lettuce? Spinach is your favorite type of lettuce? Wow. Everybody, Taylor sleeps with socks on, and she likes spinach. I like spinach too, Taylor, but I don't sleep with my socks on. I'm not a monster. Yikes. Yikes. Yeah, that's wrong.
But I don't care.
That's wrong.
I'm warm.
Like, doesn't your leg hair get like all like pushed up and awful? Like it hurts after a while. It's
No.
disgusting.
No.
Oh, you guys just shave all the time? Got it. Wow. Awful. Awful. Let my people go. It's Moses when he wants you to take your socks off. Yeah. Dope movie, by the way, Prince of Egypt. Sick. All right. Now what? Yes, ma'am.
8x plus 40 plus 6x equal 180.
Yeah. Now the question is, how does she know that? And here's how, okay? One of the ways is if you extend this out. Notice that 6x corresponds to this, and because the parallels are being cut by a transversal, corresponding angles are congruent, which means this is 6x, and these are supplementary, right? Good. Nice. Excellent. Fantastic. Next problem. Do you see it? Here's what I want you to do. I want you to stop writing crap down. We're going to have plenty of time for me to go back through and show you all this, okay? So you can copy down the 3 marks that I made, right? 1, 2, 3, 4, 5. 5 marks, okay? Here's what she's saying. This angle here is the top right corner of its intersection, right? Look at this intersection. That's the top right corner of its intersection. Do we have 2 parallel lines being cut by a transversal? We do. So that means corresponding angles will be congruent. So these 2 angles are the same. Now notice, these guys are a linear pair. You got to know it when you see it. Right? That's the definition. So together they're going to be supplementary by linear pair theorem. Do you see it now? Are you even looking at it? Some of us are. Number 4. If you think you're going to be fine if you just copy everything down that I do and then don't think about what it means, you go, oh God, that's not good. It's 1:45. You should have figured that out by now. That's not going to work, right? It's a mouse. Oops. How do you solve a problem like Maria? Work together in groups. Life is not about what you do, it's who you do it with. Oh. You're getting a 1:45 and they already know all my stuff. This is great. This is great. Yeah. I mean, whatever you want to do together. The rest of the time is yours. It's not much, but it's all we got. Yeah.
You accept.
It's a cursor.
So. All right.
So C plus 1 minus 18.
These two guys.
Because this is 9, you would get 9.
These two together being supplementary. And then your pair. Awesome. We'll make sure we got these two and then your pair. Yeah. Right? These two rolls align because they're both parallel. Okay. Awesome. Now here. Same angle.
The next 90.
Same angle. Same reason. Yes, all right. Okay. Thanks for being my partner. Promise will be a good one. I know you will.
We know that.
If you ever want to borrow these, these two angles both have Y's in them, so we can get away with it. Right, either they equal each other or they add up to 80, you know, whatever the relationship is, and we can solve problems, right? So let's focus on these two.
These are C
Question is, what is their relationship? How are they?
So it means they add
Well, ignore this
So
line.
1 plus 12 plus 1 minus 18.
Notice we have this second thing, so just look at this line and that, this line and that.
1 minus 18 plus
This thing right here, top right corner. What about over here?
same side interior.
You see it now? Again, the real trick here is, are these derivatives or are they supplementary, right? In this case, supplementary. So that means we've got y plus 12
And then we
So
know
93 plus 12 is
plus
well, let's check it.
y plus 18 equals what?
Oh my gosh.
Two y's on the side. 12 minus 18 minus 6. That's all we get to.
Yeah, because that equals.
After that, we get on to this, right?
And that is.
What do we know about this thing?
What's not just that no one minus plus
75 plus C is 90.
Oh, and this one. And this is, if this was like 72, then this one would have to be 72 as well, right? Because they're both parallel. So let's pretend we got an answer here. There's like half we put 25 seconds. How much is Z?
I did this one.
I did too.
Yeah, 90 minus 1 would be
1 equals 10 and x.
Now we know Z, now we know Y, right? Okay. Forget the math, let's just say the 5 pointers. How Good start. How do you know that? Yeah, it's the same. If we wanted to prove that, notice that this is top left corner of the intersection, and that's also top left corner, so they are. Yeah, right? They have to be. Gotcha. Yes, ma'am.
I don't know, I know that this is 8, I think, but I don't know how.
Okay, let me get that, and then I'll talk to everybody about your risk. Okay. Well, we've got top right corner of this intersection, top right corner of this intersection. So if I'm just looking at those two intersections, do I have two parallel lines cut by a transversal? The corresponding angle says that's 60, right? Also, that's not 80, is it? It's going to be 120, isn't it? There's something about this and your earrings that make you look very funny today.
Thank you.
Very articulate. That's the look, right? It's everything you ever wanted. All right, nerds. Some of y'all noticed that there's a 90-degree right here. And you remember from problem number 2 that, look, these are both parallel, so these both better be 90. Now, how do we prove that, right? Other than like, oh, they just should be, right? Well, check it out. This intersection right here and this intersection right here correspond. They're the same kind of intersection. One transversal, two parallel lines, right? So top left corner, they're going to be the same. Corresponding angles. You dig? Awesome. So X is 90. That also tells us that this is 90. So whatever that is plus Z is going to be 90. So that's going to be helpful. Now, here's the hint. Okay? The letters actually make it easier to figure out what you need to do because it tells you that there should be some relationship between these two angles. Right? Either they're going to be equal to each other or they're going to add up to 180 or they're going to add up to 90 or something, right? That way we can figure out what Y is. So the question is, what is the relationship between this angle and this angle? Right? That's what we need to know. Now, if you remove this horizontal line, we have a transversal cutting two parallels. So corresponding angle something, 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 right? That is my hint to you. Tomorrow we will discuss this. And then we're going to move on to triangles, I think. Yes, ma'am? Yeah, so look at the third page. They give you that X is parallel to M. You might want to take your time to mark that. X and M are parallels. And they tell you that Y and Z are parallel. So the ones that look like they're parallel are. They tell you angle 2 is 58 degrees, which is a little chilly. And they tell you 13 is 111. Best of luck. Find all the missing angle measures. Be ready to explain how you did it when you get here tomorrow. No need to write it down, though. See you later. McCartney, good to see you, bud. That's right. 10 days in a row for McCartney. Not yet, but I believe him. He's a good noodle. See you later, guys. Good morning, Ann. Thanks.